a couple of things I want to address. First of all, go ahead turn in the first assignment. Over here, I have several there. I have the sample test and the second assignment on the desk also. So when you turn it in, you'll have to pick up one for each. Why you put the plastic on?
So I have like several pages.
No, that's
I
good.
use a lot of paper.
Oh, you
So I
can
have like
stay.
a
You
5
can stay.
page. Oh, okay.
Yeah.
All right.
That look nice though.
Thank you.
So according to our schedule, you will see that our test is on
I
Wednesday,
got an extra sample test.
February 5th, and so we have about like
Assignment's still up there.
10 days left.
Yeah.
There's assignment number 2 you have to turn in on February 5th. The sample test you don't have to turn in, okay? It's just for you to practice. And I would really recommend that you should do the practice test. You must. Because on the practice test, we have 10 questions. And I give you another question as an extra point. And if you don't practice the sample test, I'm sure that you don't have enough time. You won't have enough time for this. Okay? I probably give you, instead of 1 hour and 15 minutes, I probably give you like 1 hour and
Like a week from
25 minutes. So I'll give you like 10 more minutes. It depends on when the next class is coming. Or maybe 1.5 hours if you really need time for that. But I really recommend that you have to do the practice. I don't know when you do. When you do it, I don't care. Okay? You must do in order to do well on the test. Okay? And you see, if you go through the sample test, there's a couple things. Oh yeah, there's one thing I want you to fix on problem number 2. Let me see. The problem is tangent should be equal to -2. Okay, sorry. Tangent equal to -2. So it's quadrant number 2. So tangent should be negative. Go ahead and fix that. Okay. Other than that, everything looked fine to me. Unless you see something like something doesn't make sense, I don't think so. Then let me know. Okay. And you see that in the sample test we have one word problem. We have a lot of picture. Okay, a lot of picture. Number 11 is a word problem also. I really want you to go through that carefully. Because I have to say this, some students already had class with me. My real test kind of similar to this. I'm not going to say this 100% is similar to this, but I just changed the number. The format, everything will be the same. Okay, I have some word problem, I have a function for you to grab, I have the picture for you to do. It's kind of the same thing. Okay, so you have to do it. Alright. A second thing, I have the permit from the math department, so I want you to sign this so that I can release I'm going to tell you where you sign it. Then I can release the video on YouTube so that you can watch the lecture one more time. Okay. I'll let you know where you sign it. There you go. All you have to do is put the date, and if you are doing enrollment, then you have to let your parents sign. Okay.
Is it today's date? Or
Today,
Video camera.
today
so
27,
it's
I
not
believe
class.
so.
This class. Because we were recording.
Time goes fast.
And Professor, how do we make sure whether we got the answers right or not on the practice test?
You can ask me.
Okay.
Somebody? You got it?
Yes, sir.
Alright.
Professor, the date we put is today, it's not the last class. Because I know last class.
Well, I didn't post the video last
Oh,
one
okay.
yet because there's some error in that. It's out of focus for about 10 minutes. Well, it doesn't matter actually.
Okay.
Okay, so you put the date, the city. I don't know why they put the city over there. We live in Orlando. So the date, the city, you don't have to check I'm gonna check my. So for the witness, yeah, that's where you're gonna sign. Okay, you're gonna sign that. Okay, then you turn it in back to me at the end of the class. Okay. All right. Everybody sign attendance sheet. Okay. Let's see what else. Everything's okay with homework? You guys have any concern with the homework? Anything? I mean, I don't think it's really that bad. Actually, similar to the example in the lecture. No. But if you guys have any question, any concern, just let me know. Okay? Thank you. Yes, as you know, we had a very bad news, right? Kobe Bryant passed away. That kind of surprised me. I mean, I'm really shocked. I'm not a fan of basketball, but I mean, that guy was so popular. Even I don't know basketball. I don't know how he played it, but I know him.
I
Yes.
have a question about the homework.
Oh, you do? Wow, great. Okay.
I took a picture actually. No, it's
Okay.
just, it's not really,
All right.
it's just this, that it's kind of like.
Let me see.
So I did it again anyways, and I didn't lose any points. But I'm just saying, like, just because you don't put like bracket. You see what I'm saying?
I think. Okay.
And there's Kobe.
I'm gonna fix this really quick, guy.
His daughter and his daughter's
Everybody, go ahead, turn it in. So they give you cosine of theta. Correction. They give you cosine of theta equal to square root of 2 over 2. And they ask you to find the theta, and that theta must in the interval between 0 and 360. They just want you to have the solution, the answer in that interval. Because it could be many solutions, because if you keep adding like to the 60 degree, then add one more revolution and give you more solution. So you have infinite many solutions. But they just want all the solution in that part. Okay, so how are we going to do this? So this is what you do. First of all, you look at the value here, and this is cosine, and the value cosine positive. What quadrant cosine positive? Anyone?
First quadrant.
First quadrant and
Fourth quadrant.
exactly. That is what you have to memorize. Okay, first quadrant and the second quadrant. So, and the second thing you have to memorize, this is cosine square root, cosine of theta equal to square root of 2 over 2. If you look at the table I give you, right, the theta should be how many degree?
45.
45 degree, exactly. So that is one of the solution because 45 degrees is inside this. That's just one. But I don't know, the question they ask you to find all of them? Hold on. They
Yeah.
ask you to find all or they just ask you to find one?
Just within 0 to 360. But
Okay.
I got all that. It's just that I put 45,315, which is
Because the 360, yeah.
Correct.
Another one, because it's in the fourth quadrant, there's one of the case I gave you last time.
Yeah.
The fourth case, you take 360 degree minus 45, which is give you what?
315.
315, yeah, exactly.
So I put my
So
answer.
that's the answer.
Correct, but I put it, but then they want it to be in particular bracket. And I don't get it why, because it's just two values.
Particular
But
bracket.
you see what was the wrong with it. Like I typed the first thing.
Oh, nah.
Yeah. So why, if you have two values, why you have two exact
You know,
values?
yeah, actually, I think that's why I hate the my math lab thing, because you don't put in the parentheses like that.
Yeah.
No, this is what that's what they want you to put. This
looks
is
like
this is
rain.
not right. This is not right at all. This is mean give you this is a whole interval. This is a whole interval. This is not right. Okay? If you want to put in the bracket, you cannot use this. You have to use this. Because only two values. That makes cosine theta equal to square root 2 and it between 0 and 360. So that I told you that kind of
Correct.
mistake
Yeah.
you sometimes you commit it
But then
because
you go to
you don't know how the system
Correct.
want the answer.
Yeah. But then you go
That's
to
the
like similar question and then you gain the point that you might have lost. So it's not a big deal. I'm just saying like it's like
So on the test, there you have a problem like this. This is what I want to see. That so you don't have to put it like this. Okay? Yeah, but that's what I already told you like before, and it happens because we don't know how they want us to write the answer. Okay? Even though we really understand the problem, but we don't know how they want us. If they put the bracket, it must be this one. Cannot be a parenthesis because parenthesis represent the whole interval. Okay, it's represent just individual value. Okay, any question?
Oh,
Yes.
actually, about the sample test.
Okay.
Is there exercises here that we haven't seen yet?
Oh, well, yeah, of course. Some topic I haven't go through yet, of course, because we still have 10 days until before the test. So this is what you can do right now. You can do 1, 2, 3, 4, 5, 6, 7. After the lecture today, you can do 8.
The lecture is gonna be 8.
Yeah, after the lecture today, you can do 8. You can do number 10 right now, because the number 10, all you have to do use the concept we learned in class few weeks, okay? After the lecture on Wednesday, you can do 9, and 11 is kind of similar to number 10, so you can do 11 if you want to. So right now, at this moment, okay, you can do 1, 2, 3, 4, 5, 6, 10, 11.
Is there any more chance we can see more like exercises like 10 and 11 in class?
10 and
Is there,
11?
like, I mean, just those like exercises you need to like find right triangles. I know.
I think in the homework we have some word problem, I believe so, right?
Yeah, but I had
Yeah.
to do the math section.
Yeah.
So I mean, I wasn't able to. Like,
If we have
follow
time,
myself.
guys, if we have time, I'm gonna give you guys a review session, but I don't promise that, okay? I don't promise that because we have a lot of things to cover. But I'll try. Let's see, okay? As long as we finish maybe 2 sessions today, then if we have time, then next time we can do something for practicing. But I don't promise. But right now you can do 1, 2, 3. But make sure that this is tangent of problem number 2 is tangent equal to -2. Okay, not 2. We'll have to fix that.
Yeah, I think so.
Okay. Well, I mean, if you go ahead and start right now after the class, I mean, you can save a lot of time though because 1, 2, 3, 4, 5, 6, 10, 11, you should be able to do it by now. Okay. For assignment number 2, which is due on February, on February. We should grab one of this. February 5th also. It's on the test day. So right now for assignment number 2 you can do, you cannot do anything yet, but after the lecture today, you should be able to do 1, 2, 3, 4. For I have to say probably 5 and 6 too, but go ahead and try 1, 2, 3, 4 first. Okay? So I don't say that there's a lot of things for you to do, but you have to prepare. That's all. That's what I need. Prepare physically, academically, and spiritually, because who knows? Even if Kobe Bryant passed away and he's just 41 years old, we have to prepare. Me too. All right. Any questions? Everybody clear? Good. So the homework homework is not really that bad, right? You can handle the homework.
Yeah. It gives you a chance
Okay.
for another.
For practice.
For another, like if
Yeah.
you miss one, you get similar question, and then that's kind of cool.
Or you
Kinda
can
same.
help me with the problem, and it will give you the steps on how to
Yeah.
go through the problem.
Like
Yes,
example.
these
That's what I have to
examples,
do.
do an example.
Okay.
I do all
Okay.
of them.
I do
And I told you,
Yeah.
if you guys have trouble,
Only
if
one.
any individual in this class have trouble, you have to get together. That's what I want. I know, you call, text, Jack, how you doing? How you do this? How you do that? Get together. That's how.
That's last minute.
Okay? Same thing when you call someone you want to hang out with. That's what you do. Okay? When I was in graduate school, that's what I do too. And it's, you know, you have a lot of opportunity to make friends at this level. So you should do it now. Because later in the future, who knows? Your classmate may be helping you some way, somehow, with job. That's the reality, guys. Alright, let's get started. So today I want to talk about another unit for measuring angle. Last time we talked about, we've been doing like with the degree, right? Everything's in degree. Today we talk about another unit, and this unit is first time developed by a guy named, let me see what his name here. I already wrote it down. His name is Roger Curtis, and the unit I'm talking about here called Radon. Radon management. It's the first time developed by Curtis. Sound very Spanish, right? But he's a English mathematician. He's a very close friend of Isaac Newton. Everybody know Newton, right?
Yeah.
There you go. And however, the radon unit first time is used not by Curtis, it's used by Thomson. Okay. First used by Thomson. Another English scientist is a friend of Kelvin, Lord Kelvin. You know Lord Kelvin? The Kelvin degree, you know, we use the 3 unit to measure the temperature degree, right? Celsius degree. Another one is what?
Fahrenheit and then
Fahrenheit, and this the Kelvin. So Thomson is very close friend of Kelvin. Okay, and every time you hear the word radon, actually you're thinking about something belong to the circle, right? Because radon sound like radius, right? Something belongs to the circle, and it is true, it belongs to the circle, and it is created, the unit is used to measure any kind of angle, okay? Any angle we can convert from the degree to radon also, okay? But first of all, let's talk about the definition of radon. What does it mean by radon mathematically? Okay, we know radon belongs to the circle, but what does it mean mathematically? Okay. I don't know if you guys remember when you have geometry in high school. You see, we have to go back to high school one more time. We talk about, you learn about circle, right? And you learn about the central angle of the circle. What is central angle? Anybody remember? I have the circle like this, and I have the center like this. What is central angle? Okay, so let's start with that definition. So central angle is the angle created by any, I say any 2 radius. So I'm going to draw the first radius like this, and the second radius like that. Okay, so this angle is central angle right here. Okay, so this is central angle. And every time the radius is equal to the r, okay, subtended by the central angle, then that angle has a measure of 1 degree. Okay, so if the arc here, I say the arc right here, okay, they have the length that equal to r. So r is the radius. Okay, then the measure of the angle here is 1 radian. Okay, let me repeat one more time. Okay, if the central angle subtend the arc whose the length equal to the radius has a measure of 1 degree, 1 radian. Okay, everybody clear? Okay, so there's a relation between degree and radian to 1 radian is actually 57.2. Just want to make sure I got it right. 246 degrees. This is the relation I want you to know. Okay. So I can say this is a 1 radian right here. Central angle has measure of 1 radian. Another, yes.
May you explain the 1 radius compared to this radius equals 1 radian?
Okay. If any central angle that subtend the arc whose the length of that arc equal to the radius,
Okay.
then that angle has a measure of 1 radian.
Thank you.
For example, over here, the radius is 2 units, for example, or 2 feet, for example, 2 centimeters or something. Then the length from this point to this point is also 2 feet. Then we're gonna have that central again has a measure of 1 radian.
Okay.
Another relation between degree and radian is if pi radian is equal to 180 degrees. And 2 pi radian is equal to 360 degrees. Okay, all of this you should memorize, especially the last two, because the last two is going to help you to convert any degree unit to radian unit and vice versa. Any questions? So on the second part, I want to give you some example of how to convert between radian and degree unit. Okay? Degree and radians. So we're going to use one of the relation. Most of the time I use the middle one. I just memorize that pi equal to 180 degrees. And totally makes sense because you look at the coordinate system. Last time we learned is on the negative x-axis. If we start from initial side, right? You move counterclockwise to the negative x-axis, then it gives you 180 degrees. Give you 180 degrees, and that part right there, that circle, that angle over there has a measure of pi radian. Okay, so I can represent this on the circle, on the coordinate system like this. For this, okay, for the middle one. So you start from initial side like that, right? And you rotate the terminal side so that the terminal side on the left-hand side, on the negative x-axis, so of course this angle right here is 180 degrees or is pi radian. Okay. And if you rotate the whole circle, then the angle has a measure of 360 degrees, or we can say it's 2 pi radian. In assignment number 2 right here, you see on the first problem, most of the unit I use over there is radian. So the assignment number 2 is about radian. Yes?
What if it's not as pretty as that? Like, what if it's at like 76 degrees?
76. Oh, if it's 76, that is where I'm gonna talk about right here. So we're gonna convert any degree unit to radian unit. Okay. Let's talk about the first one. Well, let's look at the first example here. I want to convert. Let's see. How about the easy one? Just 30 degree. 30 degree. To radian unit. How many radians for 30 degree unit? That's what it means. Okay. So I'm going to use the second relation. Okay. So I'm going to just go ahead and write down that relation pi radian equal to 180 degree. So the concept of converting between radian and degree is we're going to use the proportion concept. Proportion. So I'm going to set up this over something.
6.
I'm going to set over 30 degree on this side. Okay, because I need to match up the units. If it is this degree, then this is degree. And we're looking for this, right? How many radians? So I'm going to call this x. What's that? So what I have on the board is proportion. You know, the proportion concept we learned in the development math 2. But remember, A over B equal to C over D. I'm going to just give you a quick recall. A over B equal to C over D. Then it's implied, or it's equivalent to, anybody remember?
Yeah.
What is this?
BC.
BC equal to
D.
AD.
AD. What's that for? We usually call this, we have like the name for that. When you do this step. Cross multiply. Yes. Okay? So that is come from proportion concept. So we're going to apply this concept here. Okay. So we're going to do cross multiply. So what we're going to have? I'm going to have 30 pi, right? Okay, 30 pi equal to 180 x. Actually, 30 pi radian. Well, you don't have to put radian because it's just a unit. You know that when you get the x, the answer must be radian. Okay. So in order to get x, you just divide by 180. So divide both sides by 180. So you have, I'm going to rewrite over here, x equal to 30 pi over 180. And if I simplify, I will have pi over 6. Okay. Radian. If you want to be careful, you have to put radian. Because that's the unit. So what I have, if the angle has a measure of 30 degrees, the same meaning as that angle has the measure of pi over 6 radian. That's what I need.
So that's the final answer. There's no other.
What's that?
That's the final answer.
That's the final answer. You don't have to convert the pi to 3.14. No, please don't change it to decimal. Okay? We don't like decimal in this class. And you can do the same for 60 degrees. 60 degrees is the same as pi over 3. Okay? And you can do the same for 45 degrees. It will be pi over 4. understand that when you draw the coordinate system here, the whole thing is pi. The whole thing is pi from here to here. The whole thing is pi. If I divide the upper part, the upper part of the coordinate system into 3 parts. 1 part here, 1 part here, 2 here, 3 here, and well, it's not congruent. It's supposed to be congruent. Then of course should be pi over 3, right? Because the whole thing is pi, then you divide it by 3, it's pi over 3. Okay? And the same thing over here, if I divide the coordinate system into 4 parts, the upper part of the coordinate system into 4 parts, then this must be equal, congruent to each other, right? And this is 90 degrees. If you divide to half, then this must be 45 degrees, right? It means pi over 4, right? Any question? And you can do the same for 270 degrees. Let me do 270 degrees to radian. So we know the relation is pi radian is equal to 180. I set up the same thing. Then 270, I put it here, right? How many radian? So go ahead, try to get x. And give me the answer. Make sure don't change the decimal, okay? Keep it a fraction with the pi part. You don't have to change pi to 3.14, no, please. Never.
3 pi over 2.
What's that?
3 pi over 2.
Everybody got 3 pi over 2? Let's wait a little bit. Okay, so you're going to cross multiply. You're going to do pi times 270, right? Pi times 270 equal to 180 times x, right? You know, sometimes I have to write this x because the other x's look like multiplication sign to me, you know. It's very easy for me to get mistake, you know. Sometimes it's easy for you to get that kind of mistake. And of course, when you divide both sides by 180, you simplify that, then it gives you 3 pi over 2. Okay, so 3 pi over 2 is 360 degrees. It's right over here, guys. Okay, it's the 3 pi over 2. It's right over here. And it makes sense, though, because 3 pi over 2 actually is pi plus pi over 2, right? Pi plus pi over 2, you find this common denominator, right? Pi plus pi over 2, find this common denominator, and you multiply here by 2, multiply here by 2, right? Then you add them up, the top, so 2 pi plus 1 pi is 3 pi over 2. And like over here, we have pi from here to here. Then you add another pi over 2, which is 90 degrees. Then over here is 3 pi over 2. Any question? So I'm going to convert I can convert any degree to radian. Let's do something like weird, something like it's not special angle. Because so far we've been doing with special angle, 60 degrees, 45 degrees. Let's do something like, how about 21, for example, okay? That's what he wants. Let's do 21. Again, I'm going to write down the relation. Pi radian is 180 degrees. Then I do 21 degrees. How many? Same thing. So I cross multiply. So I have pi times 21 equal to 180x. I divide both sides by 180, so I have pi 21 pi over 180. And if I simplify this fraction, it gives you 7 pi over 60 radian. can use this relation to convert back from radian to degree too. I can convert back from radian to degree. For example, I want to convert converting 9 pi over 4. 9 pi over 4 radian to degree. So there are two different approaches here. You can set up the proportion, same thing, okay? But this is to be faster. 9 pi over 4 is equal to, pi is what? Pi is 180 degree. So you just go ahead and replace that symbol, the pi symbol, with 180 degree. And here you go. You will have your answer in degree mode. So what do we have here? 9 times 180 give you what? 1620 divided by 4, right? Give you 405 degree. Any question? If you don't remember, then you just go ahead and start with proportion. But I mean, come on. There's only one relation here, pi equal to 180. Too easy. Pi equal to 180. You use that everywhere. Okay? You use that everywhere. You just go ahead and replace the pi with 180 and everything will be in degree unit. Okay. And because it's similar to degree unit, we can evaluate the trigonometry function, the trigonometry ratio in radian unit also. So on the third part of our first Roman, I want to talk about trigonometry ratio in radian. I want to evaluate, for example, cosine of pi over 3 pi over 2, something like that. Okay? And of course, for the special angle, you can get the answer right away using the table. For example, cosine of 30 degree, which is cosine of what? 30 degree is pi over 6. So cosine of pi over 6, if you apply, if you use the table, it gives you, what do you mean? Pi over 6 is 30 degrees, so cosine of pi over 6 will be cosine of 30 degree, and cosine of 30 degree is, what is cosine of 30 degree, guys? It's square root of 3 over 2. Is that correct?
Maybe.
Yes. Square root of 3 over 2. So cosine of pi over 6 is square root of 3 over 2. You have to memorize it, okay? And no formula sheet on the test. Well, you can use your calculator, but your calculator never give you this value. They give you like decimal number. Like square root of 3, 1.73 divided by 2 give you something. You don't want to put the decimal number. No. Because no way you can cancel or simplify expression with decimal number. Okay? So you have to memorize the value. Or I can calculate sine of 45 degree, and 45 degree is pi over 4. So sine of pi over 4 is sine of 45 degree, give you square root 2. So this is special angle. What if they don't give you special angle? They give something weird, like they want you to calculate, how about, let's see, they want you cosine of negative 4 pi over 3. How should we do this? I'm going to show you, okay? You don't have to convert to the degree unit, you know. Okay, you don't have to. You can, because you already learned how to calculate the trigonometry ratio with the degree unit already. You draw the rotation, the circle, and you find the reference angle, right? But you don't have to do this. Okay, you don't have to do that in this case. You can draw the circle also, and it also based on reference angle. However, you don't have to convert it to degree unit. Okay. So how we do this? You know that this is the negative angle, and when it's negative angle, we go clockwise or counterclockwise?
Clockwise.
Clockwise. We go clockwise. So let's see. We go clockwise. So we start from here, right? This is initial side. Okay. We're gonna go like something like this. If you recognize 4 pi over 3, I can rewrite 4 pi over 3 as negative of pi plus pi over 3, right? Pi plus pi over 3 is 4 pi over 3. If I list cái mình nói này, pi plus pi over 3, I multiply here by 3, multiply here by 3, so 3 pi plus 1 pi is 4 pi over 3. So I can rewrite 4 pi over 3 as pi plus pi over 3. Everybody agree?
Yeah.
Okay. The negative side, I don't throw it away, so I just bring them down. It's negative. And because negative here means that we just go clockwise. Okay? Alright. So 4 pi over 3 is pi plus pi over 3, and pi, we go half of the circle. Pi, we go half of the circle. But this is negative, so we go the other way. So we go half of the circle. Okay, so we'll stop over here, give you pi. Okay, when we go from here, we stop over here, it gives you pi, half of the circle. Okay, then you add pi over 3, and pi over 3 is how many degrees?
60.
So you add 60 degrees more, then it should be over here. So there you go. So this one will be negative 4 pi over 3. So you have to draw the circle too. Yes, you have to draw that too. And everything is based on the reference angle also. So where will be the reference angle? 60 will be pi over 3, right? Pi over 3. Okay. So I can write this. Cosine is the second quadrant. Cosine positive or negative? Negative. So cosine of negative pi plus pi over 3 is let me see something. Let me see here. So pi plus pi over 3. Okay. So it will be negative. So I can write this as cosine of. Hold on. Let me see. So we have cosine. We here negative. Then there's another negative here, right? So it turned out to be. It's a second quadrant cosine negative. Yes, okay. So I can write this as negative
Pi over 3.
of pi over 3. Okay. Let me see this correct or not. Because this is cosine, this one cosine negative, but we have another negative here. So, yes, it is. So it gives you negative cosine of pi over 3. Because in this quadrant, cosine is negative. Okay? This negative here, it just tells you like it goes counterclockwise or clockwise. So the answer here will be negative of cosine pi over 3. And cosine pi over 3 is... What is the value? Yeah, pi over 3 is 60 degrees, but what is the value for that? The table?
1/2.
1/2? 1/2. So your answer will be negative. Yes.
How do you get to minus like negative cosine?
Okay, right here. Because the reference angle is in the second quadrant, and the second quadrant cosine is negative.
So you use.
This is negative cosine. This value here, this negative sign here, just tell you like you go clockwise or you go counterclockwise.
And what about the other p? Just
Where?
erase it? Like p plus p over 3?
Yes, pi plus pi over 3. I can
Erase pi?
yeah, because 4 pi over 3 I can rewrite as 3 pi. Oh, I can rewrite it as pi plus pi over 3.
No, I understand that. I just don't understand how like just like take
How
it
to
out.
jump from here to here?
Yeah.
Yeah, because pi plus pi over 3 is in the second quadrant. So this one I can rewrite it as cosine of pi over 3 because you look at the reference angle over here.
Oh, okay.
So it's kind of the same as you dealing with degree, but at this time you're dealing with radian unit. Okay, so if we use the degree, then over here will be what? Cosine of negative. How many degree here? Pi plus pi over 3. Pi over 3 is 60 degree, right? 60 degree plus 180 is what? 240. It's kind of the same thing. Okay, but instead of using degree, now everything you have to write must be in radian. Okay. Yes.
So the negative 1/2, what, that unit is radian then, or is it?
Oh, that's the value. So
Sorry,
it's
okay,
not the
okay,
unit.
gotcha.
Because when you evaluate a function, it's a value.
Mhm.
So there's nothing. It's no unit. We don't have cosine of pi over 3 is, for example, cosine of pi over 6 equals square root 3 over 2 only.
Mhm.
It's not radian or unit or degree over here. It's just the value.
Mhm.
Okay.
So we just ignore the negative pi
Yes,
plus pi
Yes.
over 3?
Yeah.
Okay.
You can ignore that.
It's just saying that you're going
Because it just
clockwise.
goes clockwise. That's all. Let's do another problem. Then you should be okay. Let's see. In the textbook, you see that they change it to degree. Then you do the same as what we've been doing. We've been learning, but you don't have to. You can write it like this. So if I give you something with the radian, try to use radian, okay? You don't use the degree unit. Let's see. How about this? This is an interesting one right here. Okay. I want to calculate cosine. So this is the first example. 2. I want to calculate cosine of 13 pi over 6. Okay, how we do this? Okay. So you must be able to recognize 13 pi over 6 and try to rewrite it to a sum or the difference involving the special angle. Because only when you bring it back to the special angle, you know the value. If it's not the special angle, there's no way we can calculate manually. You have to put it into calculator if it's not special. So maybe this one I can relate it to special some way somehow. Probably not, but let's see. I can rewrite this cosine of 13 pi over 6 as,
12 plus 1.
look at that, it will be 2 pi plus pi over 6, right? Two pi plus pi over 6, you find this common denominator, give you 13 pi over 6, right? Everybody agree? Look at that. So this is all about finding this common denominator. So 2 pi over 6 plus pi over 6, you find this common denominator, you multiply by 6 here. So 6 times 2 is 12 pi over 6 plus pi over 6, give you 13 pi over 6. So I can write 13 pi over 6 as 2 pi plus pi over 6. Right, okay. Now we're going to use our coordinate system now. We're going to draw the picture. This is positive, so we're going to go counterclockwise. Right. And we go 2 pi. 2 pi is 360 degrees, so we go 1 revolution. So start from initial side here. I go from here to here. 1 revolution, it gives you 2 pi. Okay? But we add pi over 6 more. And pi over 6 is 30 degrees. So it's right here. Okay, so the whole thing will be 13 pi over 6. And the reference angle is just pi over 6. Right? The first quadrant, this is the first quadrant, cosine positive or negative. So I can write this as cosine of pi over 6. Because I just apply the reference angle. And cosine of pi over 6 is cosine of 30 degrees. And cosine of 30 degrees is square root of 3 over 2. Everybody clear? Okay. So this is just the hard step is this step. You must be able to recognize this to this. If you cannot recognize, you cannot convert the fraction to involving the special angle, then we cannot evaluate the cosine function. But not, of course, not all of them we can evaluate manually. For example, if I give you cosine pi over 7, something like this, no way we can evaluate this without calculator. Because there's no way we can bring this back to the special angle. Pi over 7? No way. I don't think so. Yeah. So for this case, you have to use calculator. And if you use calculator, of course, then it will give you a decimal number as the answer. Okay? So on the test or on the assignment, I'm not going to give you anything like this. So I'm going to give you the angle that you can convert it some way, somehow, you manipulate some way, somehow, so that it's related to special angles. Okay? Everybody clear? You guys look doubtful, right? Okay, let's see. Let's see if we have time for another one. We do, but I still have to do another. Let's see. How about this? How about 11? Oh, no. Let me see. We calculate everything here. How about tangent of, so example number 3. Tangent of negative 14 pi over 3. Let's see how we do this. Okay. I know it's negative angle. I have to go clockwise. Okay. But how much I go? have to see. You must be able to convert it to some ways to a special angle. 14 pi over 3. Okay. 14 pi over 3. How are we going to rewrite 14 pi over 3 so that it's related to special angle in the table we learned?
2 pi plus 2 over 3.
2 pi plus
2 pi over 3.
2 pi plus 2 pi over 3. Let's see. Is that added up give you 14 pi over 3? Find least common denominator. 2 pi plus 2 pi over 3. If you add up, give you 14 pi over 3?
No, it's 4.
No.
4 pi.
4 pi, let me see. 4 pi. 4 pi, yes? I want to see all the yes over here before I keep going. 4 pi plus yes.
It's negative 4 pi minus 2 pi over 3.
Well, we don't do division. Yeah, we don't do division because if we do division, we cannot apply the only addition or subtraction. Only addition. So everybody agree with 4 pi plus 2 pi over 3? Right? Because look at that. If I find this in the denominator, multiply by 3 here, so I have 12 pi plus 2 pi. So I can rewrite this as what? Tangent of negative of 4 pi plus 2 pi over 3. And 2 pi over 3 is special angle right here. 2 pi over 3 is not special angle, but we can calculate it. 2 pi over 3 is 120 degrees right over here. We already learned how to do that. Okay. Alright, now let's draw the picture. 4 pi, how many revolutions represent 4 pi? 2 revolutions, because 1 revolution is represented by 2 pi. So this 4 pi is 2 revolutions. 1, 2. Alright. 2 pi over 3. We need to add 2 pi over 3 more. 2 pi over 3 is what? It means that 1 pi you divide by 3 part and you take 2 part. That means 2 pi over 3. 2 pi over 3 is the whole pi you divide by 3 part.
So 120.
And you take 2 part right here. So you're gonna go. So the whole thing will be 14 pi. Oh, I think I go.
Yeah, did you
Oh, I
wrong?
go. Oh yeah, I go. Should be going the other way around. I'm sorry, guys. Yeah.
Tripping.
Yep. Because we have to go clockwise. So 1 revolution, right? 2 revolution, and you add 120 more degree. I mean, the whole pi here divided by 3 parts. Take 2, divide by 3 part, and you take 2 parts. So you're gonna take this. So this is negative 14 pi over 3. Okay. Everybody agree with this? Okay. And where's the reference angle?
60 negative 60.
Right here, right? This is the reference angle right here. So let me use different color. And the value, the radian unit over here will be what? Pi over 3. Pi over 3. Okay. So I can write this. Tangent of negative 14 pi over 3 equal to tangent of negative 4 pi plus 2 pi over 3 equal to, this is the 3rd quadrant, tangent positive or negative? Positive. So equal to positive tangent of pi over 3. And tangent of pi over 3 is what is the value of tangent of pi over 3? square root of 3 over 3. I know, you look doubtful a little bit here. No.
I have a question.
Yes, please.
What
Any question?
What do you like took the time to separate the formula? If you could have done like minus 14 for 180 divided by 3, and you got like 840.
You can do. You want to
just
change.
like figure out is 60 the referring angle and just get it.
You can change to the degree, but the thing is this, we are dealing with radian. So when we're dealing with radian, the way you write, everything must be in radian. You can convert this to pi is 180 and you convert it to the whole degree and you do the same as the homework, and we usually do. But this is radian. We learn in radian. So everything you write must be in radian. You don't write, for example, pi over 3, you can write in pi over 3 is 60 degree, right? But you don't write 60 degree. You write pi over 3 because we're dealing with radian right now. Yes?
Isn't that equal to square root of 3, not square root of 3?
Yeah, that's what I'm saying. It's 60. The angle is 60, so the tangent of 60.
Tangent of 60 is square root of 2.
No,
Three
square
over
root.
3 over 3? Right here.
Yeah, just square root of 3.
Just square root of 3? Oh. Okay, even I forgot you. Then you have that. Good. Alright. Yeah, square root of 3. I'm sorry. Okay? But I mean, again, you can convert it to degree. But and you can get the same answer, square root of 3. But we're dealing with radian. You learn radian, so that's why you must be able to write everything in radian unit. Okay. But the concept is the same thing. You go how many revolutions, and you try to find the reference angle. But even the reference angle is in radian. It's not in degree anymore. Okay. Back in the day, what we do, we add 360 degree there, and we add 120 degree more, right? And you find the reference angle over here is how many? 60 degree, right? And you find tangent of 60 degree. It's giving you the same thing. Okay. Yes.
Could you do it like in degrees in the beginning and then convert it to radian at the end? So like, because you know like when you do like degrees, you're gonna get 60 for reference angle, then you convert it over at the way end to radians, because you know 60 is equal to pi over 3.
You can convert, but I want to see this step.
Okay.
I want to see this step. You can convert to degree, but you know all the step you do with the degree, you have to convert back to the radian so that I can see it. Because right now we're learning radian, so I want to see this step.
So
Yes.
you basically do like formula to like figure out how many times to go around?
Yes.
I mean, that doesn't really have, it's not like you go from one formula to the result. It kind of doesn't make.
Oh, from here to here? From here to here?
I mean,
Because this is the same thing last time what we do.
No.
We do 4 pi is 360 degree, right? 360 times 2 is 720 degree. Remember last time I told you when you do with the degree, I asked you to find how many revolutions that close to the value, the angle we want to by taking division, remember? Then this is 720 degree, and you add another 120 degree. Something like that, right? And this is, you count revolution, how many revolutions, 720 degree, and you ask, and you find the reference angle. It's kind of the same thing. Kind of the same thing. Any other question? Let's do another one. Let's do another one. Let's see. Let's see. How about this? Let me erase this. How about we do cosecant? Cosecant of negative 5 pi over 6. First of all, cosecant will change into 1 over sine. Okay. Now we just need to find sine of negative 5 pi over 6. R. Again, negative value mean we go in clockwise. But how much we goes? Let's see. We had to convert negative 5 pi over 6. So I can write this negative parenthesis 5 pi over 6. How gonna we rewrite 5 pi over 6 such that involving the special angle or involving the angle that we can calculate or evaluate manually? 5 pi over 6 is what do you think? How are we gonna convert this? 5 pi over 6 is something, add something, or something minus something. But that something must be special angle, or at least must be something we can evaluate manually. All the special angle we already learned, right? 0, 30, 45, 60, 90, 180, 270, 360. That was special angle. So how are we going to bring 5 pi over 6 to that? A1.
Could you do like 150 and 30 reference angle?
150. You want to bring it to degree again?
No, I mean like just to draw the picture.
I don't. Well, but we're dealing with the rating right now, so I don't want to, say everything in degree mode anymore. No.
2 pi over 3 plus pi over 6.
2 pi over 3. Let's see. 2 pi over 3 plus pi over 6. It gives you 5 pi over 6. Oh, okay. It is, right? Because I multiply over here and give you 5 pi over 6. Yes.
Well, we can do
But the
five
thing that we
reference
cannot split it up so we can side up. If we do like this, 2 pi over 3 plus pi over 6, we don't know what quadrant we have.
How about pi minus pi over 6?
Exactly. That's what you think too? Yes.
So yes, so that comes to 180.
You can do this, but if you look at this, I don't know what quadrant. You know what I mean? So if I rewrite this, 5 pi over 6 is pi minus pi over 6. And that what case is it going to fall into? What case is it going to fall into? I give you 4k last time, yes.
Could you also do pi plus 2 pi over 3?
Pi plus 2 pi over 3.
That is positive.
I don't think it's give you 5 pi over 6 though.
That's 5.
This is 5 pi over 3.
6.
Yeah.
Yeah.
What case, if you write pi minus pi over 6, what case this angle falls into? Pi minus pi over 6. Last time I gave you 4 case?
30. That's 180 minus 30.
Yes, 180 minus 30. So what quadrant is that?
The second.
The second one. Exactly, it's in the second case. If you look at last time I gave you 4k, the first one, the second one, the third one. So this is the second case, pi minus alpha. If you look at the note, open the note right away, you will see the pi minus alpha. That's the second case. So I can write this as pi minus pi over 6. But be careful, this is minus. We have to go clockwise. We don't go counterclockwise anymore. So right now, if we go clockwise, this one will be the second quadrant. Not the yes. So it's going to go like this. Pi minus pi over 6, right? So it's going to be something over like that. So this is pi over 6 right here. Okay. Then the whole thing from here to here will be negative pi, 5 pi minus pi, 5 pi over 6. So must be careful with clockwise and counterclockwise. Okay, because if you go counterclockwise, over here the second quadrant. But if you go clockwise, this is this one, because you go like this is the first one, the second one, the third one, the fourth one. But if you go counterclockwise, then the first one, the second one. But it's still in the second case. Okay, we're just dealing with negative clockwise. Alright, so this is the reference angle. Okay, so I can write this as, and sine in this quadrant will be negative or positive? Negative. So I can write this negative sine pi over 6. And sine of pi over 6 is pi of 30 degrees, right? And sine of 30 degrees is half. Everybody clear? Any other concern? So you see that on the assignment, I asked you to evaluate tangent of 5 pi over 6, cosecant 30. Oh my god, I think I give you like most of the answer here because you do just the same thing. Cotangent negative 2 pi over 3, and you just add them up. Okay. Any other question? Alright, before we finish the lecture, I want to talk about one more thing. So this is the first Roman. The second part of the lecture today, I want to talk about the application of radian measure. Application. So you see that radian measure related to the arc and the central angle. So with the radian measure, the radian unit, we can calculate the length of the arc of the circle, okay, given the central angle, okay, using this formula. The first formula is S equal to theta times R. And S represents the arc length. Okay. Theta is the measure of central angle in radian, okay? Not if you use this formula, the angle must be in radian. It's not in degree. If it gives you in degree, you have to convert to radian. R is the radius of circle. So if I draw the picture, it's going to be something like this. Okay, and this is the central angle. This is the radius R, and from here to here is the arc length S. This is theta right here. And we also can find the area of the sector of the angle using radian measure also. Right over here. So area of sector of circle. It should be the sector of disk. The circle, but I mean, if you draw the circle, it'll give you the disk. So the formula is A equal to 1/2 R squared times theta. Okay. So the area you're looking for is this one. I have the central angle. I have the theta in radian. Okay. Yes.
May you read out that formula to me, please?
A equal to 1/2 R squared times theta.
Okay, thank you.
Theta in radian, and radius is R is the length of the radius, and the area is this one.
Okay.
So you're gonna use these two formulas here to do number 2, 3, 4, and probably 5 and 6. I'm gonna tell you when you should be able to do 5 and 6. Yes.
Okay, so Because I already saw the like second exercise.
Okay.
But it's not the area of a triangle. It's like the area of like a little piece that we need to find. How do we go from that to there?
What do you mean that?
That
Like
was
on
just
the
the start.
assignment, it's
Oh.
not the triangle. It's the like.
Oh, you take the first one, you take the whole piece, right? The whole sector, right? You mean problem number 2? Okay? You want to find the center one, so you find the whole sector. You subtract the area of the triangle.
Of the whole
Yeah.
circle.
Yeah.
Okay.
Not the whole circle, like right now, the picture like this, right? And you want to find this. So you find the whole sector of this piece, then you minus the area of the triangle here.
Okay.
Yeah. Alright. So I'm going to give you a couple of examples next time, okay? I think that's all for today. If you guys have any questions, just let me know. Again, go ahead start with assignment right now. Yes, go ahead turn it in if you already signed the permit, the release. Oh.
Professor,
Yes.
when is the second assignment due?
On the test day.
Okay.
Yes.
So honestly, honestly, the first half of us. Progress. Big step. Like the first part of the lesson.